everyone, welcome to Beginner's Guide to Filecoin Chapter 9. In this video, I will give you a sense of elements of Filecoin blockchain as well as help you better understand Filecoin blockchain consensus. Here we go. Filecoin is a peer-to-peer network that stores files with built-in economic incentives and cryptography to ensure files are stored reliably over time. In Filecoin, users pay to store their files on storage providers. Storage providers are computers responsible for storing files and proving they have stored them correctly over time. Anyone who wants to store their files or get paid for storing other users' files can join Filecoin. Available storage and the price of that storage are not controlled by any single company. Instead, Filecoin facilitates open markets for storing and retrieving files that anyone can participate in. A blockchain is a distributed database that is shared among the nodes of computer network. This video covers how the Filecoin blockchain is designed and various functions it has. The Filecoin blockchain is a chain of tipset rather than a chain of blocks. A tipset is a set of blocks with the same height and parent tipset. Therefore, multiple storage providers can produce blocks for each epoch to increase network throughput. Each tipset is assigned a weight, so the consensus protocol directs nodes to build on the heaviest chain. This provides a certain level of security to the Filecoin network by preventing a node from intentionally intervening with other nodes to produce valid blocks. An actor in the Filecoin blockchain is the equivalent of the smart contract in the Ethereum virtual machine. It is essentially an object in the Filecoin network with a state and a set of methods that can be used to interact with it. There are several built-in system actors that power the Filecoin network as the decentralized storage network. System actor, that's general system actor. Init actor incentivizes new actors and records the network name. Cron actor, a scheduler actor that runs critical functions at every epoch. Account actor, responsible for user accounts that's non-singleton. Reward actor, managing block reward and token vesting that's singleton. Storage miner actor, storage mining operation and valid storage proofs. Storage power actor, keeping track of the storage power allocated at each storage provider. Storage market actor, managing storage deals. Multisig actor, responsible for operations involving the Filecoin multi-signature wallet. Payment channel actor, set up the settle payment channel funds. Data cap actor, responsible for data cap token management. Verified registry actor, responsible for managing verified clients. Ethereum address manager actor, responsible for assigning all Ethereum-compatible addresses on Filecoin network, including EVM smart contract addresses and Ethereum account addresses. EVM account actor, a non-singleton built-in actor representing an external Ethereum identity backed by SECP 256K1 key. User programmable actors, along with the maturity of FVM. Developers can write actors and deploy them to Filecoin network in the same way as other blockchains. Other blockchains refer to these programs as smart contracts. User programmable actors can also interact with built-in actors using the expected API from built-in actors. You can check out the link here. Talk on how Filecoin actors work to learn more. Filecoin uses distributed and publicly verifiable random beacon protocol, DRAND, as the randomness beacon for the leader election during the expected consensus to produce blocks. This randomness guarantees that the leader election is correct, fair, and verifiable. Nodes in the Filecoin network are primarily identified in terms of the services they provide to serve the Filecoin storage network, including chain verifier nodes, client nodes, storage provider nodes, and retrieval provider nodes. Any node participating in the Filecoin network should provide the chain verification service as a minimum. Filecoin is targeting multiple protocol implementation to guarantee the security and resilience of the Filecoin network. Currently, the actively maintained implementations are Lotus, Venus, and Forest. In the Filecoin network, addresses are used to identify actors in the Filecoin state. The addresses encode information about a corresponding actor, providing a robust address format that is easy to use and resilient to errors. There are 5 types of addresses in Filecoin for either mainnet starts with F or testnet starts with T. F0T0. This is an ID address for an actor in a more human-friendly way. For instance, F01236261 is the ID for a storage provider. F1T1. This is a SECP256K1 wallet address with encrypted key pair. Essentially, this is a wallet address generated from the SECP256K1 public key. F2T2. This is an address represents an actor that is a smart contract and is assigned in a way that makes it safe to use during network fork. F3T3. This is a BLS wallet address generated from a BLS public encryption key. F4T4. They are the addresses which were created and assigned to user-defined actors by user-definable address management actors. This address can receive funds before an actor has been deployed to the address. F410T410. This is the address space managed by Ethereum Address Manager built-in actor. The original Ethereum addresses can be cached as F410T410 addresses and vice versa to enable existing Ethereum tools to interact seamlessly with the Filecoin network. Now, let's quickly cover how consensus works in the Filecoin network. Expected consensus, in short EC, is underlying consensus algorithm used by Filecoin. EC is a probabilistic Byzantine fault-tolerant consensus protocol that runs a leader election among a set of storage providers to submit a block every epoch. Like proof of stake, Filecoin uses proof of storage to leader election, meaning the likelihood of being elected depends on how much probable storage power a miner contributes to network. The storage power of the network is stored in the storage power table and managed by storage power actor. As a high level, the consensus process relies on DRAND. All the election participants and their power are drained from the power table, which is calculated and maintained over time by the storage power consensus subsystem. Eventually, EC takes all valid blocks produced in this epoch and uses a weighting function to elect the chain with the highest weight to add blocks. The process of producing a block for each epoch can be briefly described as follows. Elect leaders from eligible miners. Miners need to check if they are elected. An elected miner gets the randomness value to generate winning proof of spacetime. If all above is successful, miners build and propagate a block, verify whether a miner won the block, and verify the leader election. Eventually, select the heaviest chain to add blocks. IPC enforces a version of soft finality, whereby all miners at round N will reject all blocks that fork off before round N to F. F is set to 900. This is important to enforce a macroeconomically enforced finality at no cost to liveness in the chain. As a decentralized storage network, Filecoin is built on proof of storage, in which miners contribute their vacant storage space to the network to store data and then provide proofs for the client to verify if their data has been stored throughout the period. Using proof of replication, storage providers prove that they have created a unique copy of the client's data and stored it on behalf of the network. Storage providers also need to continuously prove that they store client's data for the whole lifetime of the storage deal. There are two types of challenges as the part of the proof of spacetime process. Winning proof of spacetime guarantees that the storage providers maintains a copy of data at the specific time. Window proof of spacetime is used as proof that a copy of the data has been continuously maintained over time. If storage providers fail to provide reliable uptime or act maliciously against the network, they will be penalized by slashing. Filecoin implements two kinds of slashing: storage fault slashing to penalize storage providers for not being able to maintain healthy and reliable storage selectors for the network. Consensus fault slashing to penalize to sabotage the liveness and security of the consensus process. Many blockchain networks, include Filecoin, require that all validators process all transactions. This creates a bottleneck and makes it challenging to increase network performance by scaling out. On top of that, different applications have different performance and security requirements, making it difficult for a single consensus layer to accommodate the needs of the all Web3 applications. Interplanetary consensus, in short IPC, is a framework that enables on-demand horizontal scalability of Filecoin by deploying subnets that spawn their own state, validate message in parallel, interact with any other subnet in the hierarchy, as well as with the Filecoin root network. Subnets can run different consensus algorithms depending on application requirements and are particularly well suited to scenarios requiring fast finality. Want more information of interplanetary consensus? Go check out the website down here. In general, the Filecoin blockchain is a chain of tipset rather than a chain of blocks. A tipset is a set of blocks with the same height and parent tipset. Therefore, multiple storage providers can produce blocks for each epoch to increase network throughput. Each tipset is assigned a weight, so the consensus protocol directs nodes to build on the heaviest chain. This provides a certain level of security to the Filecoin network by preventing a node from intentionally intervening with other nodes to produce valid blocks. Alright, please thumbs up if you find this video helpful. More videos that you might be interested in are coming soon. Please subscribe to the channel of King Labs in case you miss out. See you in the next video. Bye!